So this is a bit of a ramble talk, where I just want to go over some stuff that I've seen in the last month, where people asked a few questions that are sort of to do with what's happening when a task finishes. And they don't really come technically together in one place, but they kind of feel related somehow. So I just wanted to talk about that a little bit and get ideas in people's heads. So two different people asked for something like, I want to essentially catch a failed task and then do some behavior based on that. So Sander at Ghent wanted to be able to substitute in a different result. And a question that came up today from the people in Dresden, they wanted to just write a try and catch block and do some other stuff. Also from Dresden came up a question about if I've got a result and I've checkpointed it. Right now, Parsl assumes that result is good and I know it's bad, so I want to ignore it. And the other way around, how can I checkpoint an exception sometimes so that it's remembered forever? And there's a sort of common theme there that is like the outcome of a task. We want to work with that. So we've got a result, we've got a future, we've got our default way of doing it that looks like this traditional workflow DAG way of doing things, but power users start wanting to do things, especially because we're in Python. They want to say things. The more we look like Python, the more they want to do things like if statements and loops and try and catch. So there's this sort of tension. On the left, there's what I call DAG brain, which is that's what your workload looks like. You draw it out on a plane. It doesn't have loops. It doesn't ever change. Tasks start turning green at the top until one of them turns red. And then when one turns red, everything depending on it turns also red, right, and fails. And you don't get any control of that. On the right-hand side, at the top, up here, and we've got Python syntax of sort of the same thing. We're going to run task one. We're going to feed its output into task two. We lose the concurrency here, but the same output goes there. But in Python, at least sort of from this version of Lisp that arose in 1972, we've had the technology to express things like this, where you can catch an exception and do something else. So if you've got programming language brain, doing this kind of stuff is pretty natural, right? And Parsl's been getting more Python-y kind of stuff. Like we started historically trying to do a sort of VDL Swift kind of thing, but using Python syntax, which is what the left looks like. But now we've got a lot more Python stuff going on. So beyond just having tasks that succeed or fail, we've already got a bunch of ways to operate on tasks. We've got checkpointing, and checkpointing looks when you ask to do a task, we look at the task and say, well, actually, I think I can throw away that task and replace it with the outcome that I got out of this database. And we hope that that is an equivalent result. And we've got join apps, which is this thing that lets us write a little mini Python program that can look at stuff that's happened already and launch tasks dynamically, which is also a thing you can't express in DAGs, but you can if you've got a sort of programming brain where you imagine running code all over the place. We've got retry handlers, which can look at failures and decide how retries happen. So that's a little bit of catch functionality, but the only thing it can do is really decide to do a retry. So there's all these sort of ad hoc ways to operate on tasks and look at the outcomes and do stuff with the outcomes. So to address the stuff that we had, those questions that have come up earlier, I ended up making two different pull requests, and I've got an idea I want to try as well. First one is checkpoint plugins, yet another checkpoint mechanism. The code's already pretty amenable to having a checkpoint layer put in. All that PR does really is move, makes an interface definition and moves our default behavior into an instance of that. And then that lets you put in your own user policies. I made a thing that lets retry handlers do other stuff. And I also have an idea that I want to use Python's async syntax for sub workflows. So checkpointing, what that looks like now is when a task finishes successfully with a result, that goes in the checkpoint database. If it fails, we don't checkpoint that failure. So we're assuming that failure is always transient. That's one of the questions that came up, is how do I say, actually, I don't want failure to be transient. Like, I know this is a bad argument. I want to remember that forever. And then we load all the results from the checkpoint database. We assume if the results in the database is good. And that's another question that came up. Users saying, I know when I invoked this function with this particular set of parameters, the results are bad. Don't load those checkpoint values for those results, but do load all the other checkpoints. So with this PR, you can stick a little hook in around the various checkpoint calls, and you can put your own Python policy in that does that. It's pretty straightforward. I think that's well on the way to turning into something that can be merged. And it's just the more of the classic thing I've been doing in the last few years of saying, you've got policies, you can express them in Python. Maybe we have a library of different policies, but you can also put your own stuff in there. The retry handlers, what you can do in master at the moment is you can look at a task. When a task fails, you can look at that task and you can look at the exception and you can say, all right, are we going to retry or are we not going to retry? And are we going to fail? Once I did that, it became apparent that you can start doing other stuff in there because it's just Python code. So you can modify the task. So Logan's little machine learning loop stuff that occasionally gets a bad set of parameters and has to rerun again with different parameters. You can do that here. You can say, oh, we're going to retry, but what we're going to retry is actually a different kind of task. But that's all you can do. You can either rerun a maybe modified task or you can fail. What Sander wanted to do in Ghent was say, all right, I've looked at these retries and I've decided that I want to actually make some kind of return value that says, all right, it failed in this particular way, and then pass on that onto subsequent tasks in the pipeline, which is something we can't do at the moment. If you failed, you failed. Nothing downstream gets to run anymore. So this PR I'm less fond of, but it got me thinking about things a little bit more. And one of the examples down at the bottom is you might want to say something I fabricated was, if 95% of my inputs didn't fail, then we can compute the mean of them. Right? I don't care if a few didn't work, but we've got enough, which you can't express in Parsl easily at the moment. Maybe that's the sort of thing you'd be able to do with this. But then it got me thinking, vaguely, I've been wondering about this and I thought about it a bit more, is Python has this coroutine syntax, which mostly is based around the await keyword. So that's mostly used for the async IO library, but it isn't tied into the async AI library at all. You can use it for whatever coroutine engine you want at all. So there's this syntax that I can imagine where you have an async app, and I'm going to say, run this task, wait for the results. Run this task, wait for the results. We can put Python control structures in here, like a try here, but it could be loops or whatever. When we get down here, run the next task, and when we get the result, return the result. And using coroutines here, I think we can get some of what join apps are all about. So the reason for join apps was, if you say something like this, and call result on a future, that blocks an entire worker for many hours or days while it waits for that result to happen. And what we can do with coroutines is say, all right, freeze this bit of code where it is, stick it off somewhere else, and the DFK can wake it up to run the next little step and freeze it again. So the DFK gets to control sort of progress through this as these tasks complete. And I think, for example, that would be enough to implement normal Parsl retries. you could do that. You can do loops, you can do a catch. That's enough to do retries, I think. And I think that all the stuff that Sander actually wanted to do with retry handlers before, probably you could do with this. So this feels like quite an interesting forwards exploration of what join apps do at the moment, but a bit more Pythonic with more structure. Yeah, so this is sort of my quest for Pythonic abstractions, really. We've got all these ad hoc features like handlers for this and handlers for that get added over time. And I kind of want to push on exploiting the user familiarity with Python that we have. We have people who are really good Python programmers now as users. So there's sort of two directions for solving some of this and solving other problems and exploring other directions. Is one, how can we apply Python code to every task without having to write it in the task? That's what checkpointing looks like. That's what retries look like. It's also what file staging looks like, for example, to go off into other parts of Parsl. And how can we let individual tasks look more like regular Python programs with control flow and exceptions and loops and if statements and things like that. Yeah, so that was just a bunch of vague thoughts. That's the end of my talk. There isn't really any great point out of it. It's more like here's a direction that we could be exploring.